All right, let's go ahead and get started. Welcome to the first OpenZFS leadership meeting post Dev Summit. I hope everybody had a great time at the Development Summit 4 weeks ago. We have a couple of great ideas on the agenda today. First one we were just discussing. Folks who attend regularly may not benefit from this much, but there's a lot of people who can't attend or attend sporadically, and the meeting notes are really useful to them to see what was discussed and decide, when they need to go look and read, watch the video for the details of something that was interesting. Thanks a lot to Seraphim for taking those notes for the past several years, I think. And he needs a little break. He's been at it for quite a while. So we're looking for volunteers, and thanks to Christian for volunteering to do that. That's much appreciated. And I'll send out those meeting notes if folks haven't seen them already. I send them out to the mailing list, developer mailing list after the meeting. All right, cool. Thanks a lot, Christian. So the other things, Jason Lee had some things to discuss about using ZFS with hardware accelerators. And I think, Jason, you said you had some slides you wanted to share to talk about your idea. I see you're there, but you're muted still. Connected on a phone.
Can you hear me now?
There we go. Yep.
Cool. Can you see my screen?
Yes, I can.
Alrighty. So, hi everyone. Like Matt said, I'm Jason Lee from Los Alamos. And the plan for today is just to talk about the ZFS interface for accelerators and a companion piece called the Data Processing Unit Services module. So this is going to be super high level and is more meant as a feeler to get people interested in our work and to see if we can, to see how many people are interested and maybe get comments on it when I eventually open a pull request in the OpenZFS repo. So the motivating reason for why this work exists can be summarized by this graph graciously provided by Brian Atkinson. At the lab, we like to run RAID Z2 Z-pools with compression and checksumming enabled. Specifically, we like to run gzip as our compression algorithm. On this graph, you can see with no compression, we get about 8.5 gigs a second of throughput across a large number of IO threads targeting a single file. And slightly under that line, we have LZ4 compression, which is about at 7.5 gigs a second. So we have some performance degradation due to the fact that there is now overhead for compression, but it's relatively small, about only a 10% drop or so. However, at the very bottom of this graph, you'll see a nice straight red line, which is the gzip throughput. That's a massive drop-off, which we would prefer to not have. So, and the basic reason for this is because compressing data with gzip on a general purpose CPU is just really, really slow. Fortunately, there are devices called computational storage devices and computational storage processors, which are currently being developed. They have hardware implementations of operations such as compression and checksumming and erasure coding, which happen to overlap incredibly well with the features that ZFS provides, which makes ZFS an ideal candidate for offloading operations. As a side note, I do know that there is code for Intel QAT operations. Unfortunately, that doesn't run on my AMD boxes, so that's a slight problem. So what was done to enable accelerators for all machines was to add a shim layer into ZFS so that data can be offloaded onto hardware accelerators, while ZIOs and their corresponding ABDs still follow the ZFS code paths. This allows for alternative implementation of the same functions so that if for whatever reason accelerators are not available, the data sitting on storage can still be read out or read in or out, because all of the data looks like as if it was written by ZFS with no changes. So here is a diagram of the write pipeline with ZIA enabled. At the top is a highly simplified diagram of the ZIO write pipeline. On the left, we get a ZIO plus its ABD. We send it into compress, do a bunch of checks, do a transform push, I think, and then pass the compressed data into checksumming, RAID Z, VDEV disk or VDEV file code to issue the IO, and then eventually the data lands on storage, which in this case is NVMe. So with ZIA enabled, when data enters the ZIO write compress function, the ZFS shim layer will see, hey, ZIA is enabled, ZIA compression is enabled, this data is not offloaded, so let's offload the data onto the hardware accelerator and compress it. So when this data is offloaded, the ZIA interface returns a handle for ZFS to keep track of. This handle will be stored in the ABD as a void star, so it's opaque. And ZFS has no idea what it is and can't do very much with it except pass it around. So then the ZIO is passed into the checksum stage, and the handle is passed into the ZIA checksum function, which in turn calculates the checksum of the data. And then similarly for RAID Z, the data is split into chunks and the parity columns are calculated. And for RAID Z, in addition to the ABD data itself, it also will hold another ZIA handle inside the RAID Z row struct. And finally, the data is passed into the VDEV disk or VDEV file pipeline stage and written out to storage. So just during normal operations, data will never be brought back into memory, other than minor stuff like return codes or checksums, because checksums are needed in block pointers. But in general, the actual data in the ABDs will never return to memory. So there will not be a cost of constantly transferring data back and forth between or on the PCIe bus. However, if there are errors in the operation, for instance, you pass in the data is passed into the checksum function when you have request flexure 4, and this hardware accelerator for some reason doesn't support flexure 4, then yes, the data will be passed back into memory and then offloaded later. But hopefully this is not a normal occurrence, so you shouldn't incur that cost too often.
This is really cool. Can I ask a question about that previous slide?
Sure. Sure.
So it looks like in the diagram here, like the ZIO pipeline is still the thing that's like driving this. So every stage of the pipeline is still executed like normally, and then it's just passing this like after the compression, then we go back to doing the pipeline. It goes to the next stage. Maybe the next stage is checksum, and then it's going to pass the handle to the ZIA, callback or whatever. Is that, do I understand that correctly?
Correct.
Okay. And
So,
and how integrated is this with the ABD stuff? Like, for example, let's say that we add some other stage in here into the pipeline that needs to process the data, and maybe it needs to process it on the main host CPU. By like just like calling the ABD, iterate or ABD copy kind of functions, is the ABD code then going to know that, oh, like I have this ZIA handle, I need to like copy it back from the the external board memory into the main memory so then I can do it? Or like, do we risk like looking at the main memory, which is now out of date because it was, not we don't have the compressed version or whatever?
So it is not integrated with ABDs at all, except for that ZIA handle inside the ABD. If you want to bring data back, you pass a fully allocated ABD into the callback, and assuming this is implemented correctly, the data will be onloaded into the ABD according to whatever ABD type it is, whether it's linear or scatter or gang.
Cool. Yeah, I guess my main concern is just like people like the normal case is going to be like not having this external processing unit, and we want to make sure that we don't like break the use of the external processing unit by like adding something that you weren't thinking about into the ZIA pipeline. And so it would be nice if there was a way to, for the, like at the ZIO layer, to have some kind of error checking or something to make sure that the data, like if there is a handle, then, and you're trying to get the data, then you have actually like copied it back, like have some assertion that you already copied it back, or some way of checking that, you know what I mean?
Or could we do something like when you copy it out to the ZIA, you like freeze the in-memory one,
Yeah,
so
like
it'll
you
assert
flag
if
it
it ever
somehow.
changes. Yeah, and so you know that you're never allowed to touch that until you've copied back if you need to modify it.
Yeah.
So the current check I do is simply checking whether or not the ZIA handle is null. If it's null, it was not offloaded. If it isn't, or sorry, if it's not null, it is offloaded. If it is null, it is currently in memory.
Okay, so yeah, so basically have some check where it's like, oh, you're trying to do ABD copy whatever, or ABD iterate whatever. If their handle exists,
Right.
then we explode it, or we explicitly copy it back, or something like that.
Right, but that code would not be in the ABD itself. It would be part of the small modifications inserted in front of the operations. Like right before doing the checksum, you first check whether or not this data is offloaded or not.
Yeah, but what if I'm like doing?
Can we add the check to the function that pushes the pipeline forward for each step or whatever, so that if we add a new step in the pipeline, we won't accidentally forget to add that is ZIA handled null check to it, right? That's what you're saying, Matt?
Yes, I think.
Yeah. I'm sorry, I don't want to like rat hole too much on this. But maybe just take the high level point that like, let's find ways that we like, this sounds really cool. It sounds like you've integrated it really slickly with the ZIO pipeline. At a high level, let's just additionally think about like how we can add safeguards to make sure that we don't, accidentally get confused about where the data is and then, operate on stale data or something because of that.
Right. These are the comments I'm hoping to get, like I guess now, or if I ever, or when I get the chance to open a pull request. But right, this presentation is just super high level. Here I did a thing.
Yeah, this is really neat. I like it. Feel free to go on to the next slide if you want.
All right. So the other thing we did is offload resilvering. So normally when you resilver the data, each stripe, or I guess row in ZFS terminology, is read in, and then the data is reconstructed using the data that was read, and the checksums are verified. And if it is successful, the parity bits or parity columns are recalculated and compared against the existing data. And if for some reason there's an error, you recalculate, you reconstruct the columns using, I believe, permutations of the data that was read off. And similarly to the write pipeline, all of these operations are mirrored in the hardware accelerator. You offload data from right before reconstructing the data, and instead of calling the ZFS reconstruction functions, you instead call the ZIA RAID-Z reconstruct function to calculate the reconstructed data from within the offloader. And similarly, recalculate the checksums and recalculate the parity columns. And then eventually issue any repairs that have to be made to the storage through ZIA instead of through the ZFS vdev disk or vdev file functions.
This also sounds very, very cool and very tricky. Just background info, how like the RAID-Z reconstruction is non-trivial and non-standard. How is this like is this data processing unit like an FPGA that you've like programmed to know how to do the like that RAID-Z math stuff in parallel, or how does that even work?
So ZIA does not control the mapping or any of that stuff. All it does is take the actual the payload of the ABD, and operate on that. So ZFS will still hold the mappings. And
I guess my question was like, when you're operating on that to do the like reconstruction math, how do you tell it how to do the reconstruction math? Like, I don't know anything about these cards, so, or whatever it is, data processing units.
Or actually, could you repeat that? So you're saying that the ZFS RAID, the RAID calculations are not standard?
Well, they're not like, I mean, they're not like something that was in use before ZFS, as far as I know, like the math stuff.
Well, I presume we are telling, the plan is to tell the accelerator vendors to implement RAID-Z correctly so that ZFS alone can still read the data that they write.
Oh, okay. So it's not, let's see. So you're just going to get the vendors to implement, like, you're going to send them, RAID-Z, vdev RAID-Z.c and be like, hey, code up this math in hardware. Basically.
Don't hold me to this, but probably.
Okay. Well, that's cool. Yeah, I mean, that math, it's not like, it's certainly not impossible. I mean, I know that the like vectorized routines have been written for a bunch of different, vector instruction sets to accelerate the RAID-Z reconstruction, which is, pretty complicated, especially when you get to RAID-Z 3, with 3 disks died. It's pretty involved. This sounds cool.
Cool. So the original plan was to write the shim and then have it link into an existing bit of glue code that talks between accelerators and the ZIA shim. Unfortunately, that was just not a good design. It worked to get me started, but it wasn't extensible. For instance, if we have multiple accelerators and we want to switch between them, we couldn't just do that by linking ZFS directly to the accelerator glue code. Instead, we created the data processing unit services module, which acts as a registry for accelerators. Then vendors implement what we call providers, which is the glue code that talks to their accelerators, which allows us to turn accelerators off and on or switch between them or any number of other operations that
yeah, like you might have one accelerator that does gzip and one that does RAID Z, or maybe you have like 2 that do gzip and 3 that do RAID Z, and you need to like multiplex over them, right?
That could work, but that was not the plan. We were hoping to keep data offloaded on the same accelerator throughout its lifetime, so we don't do crazy copies left and right.
So you would have like the idea here is that you'd have multiple accelerators, each of which provides all of the functionality that you need.
Yes.
Okay.
And then zpool 1 would use the one accelerator, zpool 2 would use a different accelerator.
Okay. Is there any reason that you couldn't like have? Is there any reason that you couldn't just have one big zpool and like load balance across your accelerators?
Probably not. I guess we haven't really thought about that. We're still trying to sort of get all the issues ironed out. So
yeah, I mean, in the general use case, like it would be nice to have flexibility there, right? Like it would be nice if you could have any number of storage pools and any number of accelerators, and it just like uses them to the maximum that we can.
Right. This diagram just shows the general ecosystem of how ZIA will be used with the data processing services module. So commands come in from user space on the left into ZFS with ZIA enabled, which in turn sends data and commands down into the DPUSM, which talks to the glue code, the providers. For instance, if a software provider or a Bluefield 2 provider, which in turn communicates down to PCIe bus to wherever the accelerator is, which then finally writes to the backing storage. So the DPUSM has 2 interfaces. One side will be used by the caller, for instance, ZFS, and it will have a non-restrictive license so that it doesn't clash with, say, CDDL. And the provider side will have a GPL license, so that implementers may use the Linux kernel functions that are GPL'd. So that's all I really had. Hopefully people are interested, or I guess find this interesting, and will provide tons of feedback about this.
Yeah, this sounds really neat. How would this relate to the Intel? I forget the acronym now, but the
QAT.
QAT, yeah, like the QAT offload. Like, could that become one of these providers that plugs into the DPUSM, or would that have to remain kind of a separate thing?
I believe so. I've only seen the QAT code in a few places, but the modifications weren't terribly big.
Yeah.
I imagine you could just extract it, write a provider, and that's it.
Yeah, I don't remember how exactly the memory management with the QAT worked in terms of like, providing like copying the buffer and then like do you get a handle that kind of lives across multiple invocations or what?
Right.
But I guess even if
Right.
it's not as flexible, hopefully you could still fit it into this API, even if the performance wasn't as good as it could be with one of these custom designed boards.
Right.
I like this is very interesting to me, but it's not really in my like personal use case. So I'd definitely be interested to hear from other folks about both technical, like how this would work, and also like, is this interesting to you? And I imagine people might be curious about like how they could get their hands on these fancy accelerator boards.
I'm not sure how people would get their hands on the accelerator boards. Might have to talk to Brad Settlemeyer.
Maybe a question about like the memory model. So the idea is like all the accelerators will be attached to PCI Express. There is no idea for like tighter co-processors, which have appeared in more recent ARM processors. For example, there are like ARM processors with pretty tightly integrated FPGAs and so on that could be used. Have you considered those, or is it fully limited to PCI Express?
Well, and it wasn't designed with PCIe specifically, but that was the general thought, since NVMEs are behind PCIe buses.
Sure. Okay.
I mean, it seems like
But,
architecturally.
yeah, if we can figure it out, why not? Oh, sorry.
I was just going to say, it seems like architecturally, the only thing that might be really different there is the need to copy the memory out to external memory store versus like presumably those more tightly integrated things would just be using main memory.
Yeah,
Right.
exactly. That was my thinking.
Yeah. But you could imagine like maybe the like handle is just like, oh, the handle is just like a pointer to main memory. And the copying to and from the handle is just like, here's the pointer. So it seems like the general thing that's being designed here would probably work just fine for a more tightly coupled accelerator.
Yeah, I mean, like if I interpreted the first slide correctly, then, or one of the first slides, then the idea was to directly copy, like tell the NVMe device, copy from the accelerator onto the NVMe device if possible. And in that case, like we have to make sure that it's DMA copyable memory on the host side and so on. A few implications there. But in general, yeah, right. Should be flexible enough.
Other questions or comments?
I guess my question would be, how far in the future do you think you see this being minimally viably usable? Because it sounds like a bunch of it is still at least pending. Let's go tell the hardware vendor to go implement it, which sounds like a longer timetable.
So we do in fact have one prototype piece of hardware that we're trying to implement a provider on. So hopefully not far in the future.
I just one other comment. I know with the QAT, there was maybe a minor issue with gzip in that the way they implemented it meant that the same block compressed with the CPU would have a different checksum than the block compressed by QAT. Like it was decompress compatible, but it wasn't actually byte for byte the same as if you had compressed it on the CPU. They used I think a slightly different table for the gzip that resulted in it being faster, but not actually the same. And it just might be something you want to watch out for, or something maybe you can test for when implementing gzip and hardware on this.
Okay.
I think that isn't like a hard requirement.
No,
but
just
something to be aware of. Like
aware
if it could be exactly the same as the software encoding, then that would be nice. But if not,
it's just something to be aware of. Yeah.
Yeah.
So would that cause problems, or like if the checksum is correct, Does it matter?
Only in the case of like compressed arc is turned off and you have an L2 arc. So not in most deployments. No, it wouldn't matter.
I see. Okay.
Yeah, there's some
Actually,
clear cases.
Alan, didn't you suggest anywhere? Like, I don't remember if it was you, but you suggested to turn on compressed, like require compressed arc at some point. Or am I mixing
We
this up?
looked at it, but there are enough use cases where it makes sense to
Okay.
turn it off that yeah. I'm looking at
Okay.
other ways to try to solve that problem.
Yeah, I would still love to get rid of non-compressed arc, despite those use cases, but maybe that's not practical. I don't know.
I was going to say, if being byte identical isn't required, boy, have I got a bunch of upgrades to submit PRs for.
Yeah, maybe someday we can figure that out.
Yeah.
One question for the project, Matt. As you know, assuming that we see kind of vendors coming into this space and kind of creating these hardware platforms, how does the project ensure that as we make changes, we're not breaking these things?
Yeah, I think that's a great question. I see on the slide that's up now, you have something called a software provider. I'm hoping that maybe that's like, something that can be a provider that hooks into this interface, but is implemented in software and doesn't require any special hardware. That would be really nice for testing. If we could have something like that where it's like, yeah, technically it's just in software. Technically, you don't need to copy it off anywhere else. But for testing purposes, we're actually going to copy it to some other memory so that we can catch any bugs related to, copying or not copying from the main ABD buffer. I think that would be ideal in terms of testing.
Right. I will have to check with our legal people about that.
In terms
Or
of
IP
like
people,
open
I guess.
sourcing the software provider or what?
Yeah.
Well, presumably it's GP, like by making it GPL2, aren't you like intending that all the providers have to be open source?
Right.
Right.
Well, how does this work?
I mean, I'm
we'll
not a
have to keep
lawyer,
private copies of- yeah.
but talk to whoever you need to, but like, it sounds like that would be a great way to enable testing.
Yeah, I think
Right.
that'll make it easier, to even like get some of the stuff into the main repo, because otherwise, like, I can just imagine you guys are going to be like fixing bugs as somebody comes out with some new thing in the pipeline, and then all of a sudden, like this stuff just starts blowing up. And unless you're tracking those changes closely, you may not recognize them, and then God forbid, like you end up with some corruption or something.
Yeah.
Right.
I should mention, I don't think the QAT stuff has anything in the test suite right now.
Yeah, that's probably already the case with the
Yep.
QAT potentially
Right,
bit
because it
rotting.
would require the hardware to be able to test it.
Yeah, that's why it would be nice if this becomes kind of a generic framework and we do have something like a software provider or a test framework or something, then we like get rid of QAT, bring it into this framework, and then provide ourselves some protection there and consumers of that protection.
Yeah, I mean, I could imagine that this becomes like there is no non-DP USM. Like DP USM is just like, that's the interface for doing doing like bulk operations on data, and all the current software implementations move to the other side of that API as part of the software provider. And then all that you have is a switch that's like, oh, like, are software providers operating in place, or are software operators gonna like be copied out to another buffer for testing purposes? That would be cool. The other kind of high level question I had was, do you know if these hardware providers are going to be selling this hardware to the general public, or is this a special, for government consumers only kind of thing?
I do not know.
Okay. Yeah, I think that getting it accepted upstream, if the only use case of this was if you're a special entity that can purchase this special hardware, then you can use the special thing. Then I think that it would be a hard sell to get it integrated upstream. But if either you can hook into software providers, hook into the QAT that's generally available, or if this special hardware is is purchasable by other entities, then I think that there's then it makes sense to get this upstream so that people can use it.
Okay.
Hopefully that
Yeah.
gives you some decent feedback on what maybe if you find out that they're not going to sell it generally, then that means that you need to put some more emphasis on the software providers or hooking into other hardware accelerators that are generally available, and and of course it also just happens to work for your use case as well.
Right.
I mean, I see you have GPU provider. Obviously, there's a lot of GPUs you can buy in the open market. If somebody's going to write a, RAID Z vectorized math for GPUs, that would be really cool too.
And I'm sure the SHA-256 one is about as optimized as it can be at this point, right? For GPUs. Because that's what Bitcoin and so on uses.
All right. Yeah, maybe you get one of those Bitcoin specific cards and use it for your SHA calculations. Cool. Did you have any other questions or things you want to get feedback on, Jason?
I have one last question. So as I understand it, this DPUSM will be a separate Linux kernel module, and ZFS would just use the exported interface of it, just like any other file system would use it. Will this DPUSM do any kind of resource multiplexing, or will it expose what will the interface look like for ZFS to give me an accelerator for gzip, give me an accelerator for RAID Z math, whatever? If it handed out that accelerator, will another Z pool be able to use it, or is that accelerator gone now? And how do you handle multiple Z pools on the system with a single accelerator?
I believe currently, in theory, we can have multiple users of the same provider. I haven't really tested that out because as I mentioned before, we're still getting things to work. But I don't believe there's any reason why we can't use a provider, have multiple Z pools use the same provider.
Okay, then the provider has internal parallelism or whatever, because otherwise the operations would get slower as work on the accelerator is pending.
Right.
Okay.
Right. We should probably add some status checkers for our hardware accelerators into the DPUSM or something like that to make sure it doesn't get overloaded.
Yeah, some kind of observability into the queue depth.
Right, because I mean, at some point, it may become the bottleneck, and then you want to back off and say, don't put everything on accelerator.
Right.
Well, I think with QAT, it only made sense if your buffers were big enough. So if you were trying to checksum only 4 or 8K, the overhead of copying out to PCIe and back wasn't worth it. But if you were checksumming 128K, then it was. and it might make sense to be able to decide which ones to offload and which ones not to on some threshold. Although, part of the design here is to, copy it off once and do all the operations on it instead. And so it definitely reduces the cost there.
Cool. Thanks a lot for this presentation, Jason. I really appreciate you coming and bringing these ideas to the team and getting the feedback early on, and engaging with the community. I think that there'll be a lot less surprises later on. When you want to get it integrated. So
right.
Next steps. Could you send this a link to your slides to me, just so that we can?
I don't have this online. Can I just email it?
Yeah. You can just email a PDF or a PowerPoint or whatever to me, and then I can put it up just as part of our meeting notes.
Okay.
And then feel free, when you make progress on this and you have more questions, feel free to come back to this meeting and have another discussion, or open a pull request whenever you're ready.
All right, cool, thanks.
Cool. Looks like we have a few more things added to the agenda. I'm gonna, let's see. Let's do, Rich, are you here? Do you want to talk about the encryption stuff, and then we'll close out the meeting with the requests for code reviews?
Works for me.
Cool. So I don't know if you have if there's enough time to go over everything that you wanted to today, but why don't we at least get started?
It's fine. I was planning on summarizing it very briefly anyway. All right. So it turns out encryption has bugs. Surprise. I know it's shocking, right? Yeah. But I went through, I can share the spreadsheet I produced. I went through all the bugs tagged encryption, and I gave them a first pass. And it turns out that they all fall into one of three categories, more or less. There's a couple of outliers, but broadly. The big one is, I wish I'd made slides thinking about it. It didn't occur to me that that would be useful here. Whoops.
Sorry.
The big one is a bug where you end up with somebody's not ref counting D nodes correctly. So you appear to end up with two people thinking they have the only reference to a D node, and one of them frees it, and then the other one is very sad.
Yes.
And as a result, this can produce all sorts of different stack traces because, one of the threads is in the middle and already checked this is all valid, and then it comes back and suddenly it is not. I've been looking into this for a bit. I have had some trouble reproducing it on anything that's useful. For some reason, I've only been able to reproduce it on random not x86 architectures. All the reporters are from x86 architectures, but I have a ZFS test suite loop that will do it inside of a day on my Spark board, and I left it running for 2 weeks on the x86 board, and it's perfectly happy with its life choices. So software.
Very annoying.
But all right, I should have led. I mostly came here to ask for if anyone would be willing to spend a bit of time and offer insight, because I am not at all familiar with this code. I have tried reading it, but it's somewhat difficult to run down what might be going wrong. And the bugs, at least, all of the bugs that I'm looking at seem to go back to when encryption was first integrated. The one I'm talking about right now, the earliest report is pre 0.8.0. So I can't really bisect my way out of it.
Yeah. And is this bug that you're talking about related to send and receive? And encrypted send and receive, or is that not on the scene?
I think maybe. So like, I haven't seen any proof that it has to be send receive to get this bug. I have only seen it reproduce with send receive. But
Right.
you know, the other one that I'm going to mention is a set of bugs with send and receive explicitly. So, you know, until I have a root cause, I probably.
Got it. All right. Yeah, that's also annoying, but not too surprising.
Yeah. A bug which seems to be the same thing on Illumos ate someone's data. So, you know, that's good.
Yeah, that's not great.
So if anyone would like to ping me after the meeting and like talk about this, I would love to. It would be nice to get these resolved because people keep coming and reporting them. And we keep going, yeah, we know. The other one, the other one is a set of bugs where you do incremental send receive and it nukes your data set. So you can't open it anymore. There seems to be at least 2 different ways this works. One of them is the user object counting problem where it, if I understand it correctly, it copies the user object counting data that it got from the send stream in. And because I think it's the MAC doesn't match, then when it goes to try reading it, it gets upset later. There was a PR that fixed this, but it was broken for some Git release or some Git versions that never made it into a release, so it got reverted. I don't know why it didn't get fixed again since, but I was going to look at these in order, and I've been looking at the first one mostly so far. The other bug with incremental send receive is that apparently sometimes if you like did a change key or change key -I on the receiver, and then you go to send back the data or receive data, having done that, it will clobber the wrapper key incorrectly. So the next time you go to do load key, you will be sad because the key will not match what is actually encrypted on disk. Like it will update what key it thinks it should be using to unlock, but not actually re-encrypt the actual key or something.
Yeah, those all sound like tricky bugs. I think this is a great opportunity for like someone or some company that's using encryption to, you know, step up and be a leader in this area. Like it's hard for me personally. Like I know a little bit about encryption and probably more than I would like to about dnodes and send and receive. But you know, I have a lot of other stuff to do, and I don't use encryption at my job. So there's probably other people who are using encryption at their jobs that might be hopefully more motivated to take this on and, you know, lead us to a encryption, ZFS encryption correctness wonderland.
Oh, I would hope so, but I'm not actually convinced anyone is using it at a large company.
I don't know about that either.
That's the problem. Yeah.
Rich, we talked about this a few days ago, and I didn't get whether you got a working reproducer for at least the node drive counting thing.
Yeah, you did suggest that I make a minimal reproducer. I discovered that while it does reproduce happily on a KVM PPC64 guest, it does not reproduce happily on a QEMU PPC64 guest, which rather limits how useful making such a guest is.
Okay, so you need PowerPC hardware with KVM on top, and then you can reproduce it in a VM fairly easily.
In a PPC64 VM, that appears to be the case right now. I do not know why, but it definitely reproduces very readily on one and not the other.
Yeah, but it sounds like if somebody, had the time to work closely with you, then, you could iterate together on getting more info from that system that does reproduce it.
Yeah, I mean, I have a number of VMs and real hardware that reproduce it. The problem is that the list of ones that kernel debuggers work on is much more limited.
Yeah. Well, printf debugging, here you come.
Yeah, that's where I've been.
Have you considered that is it related to how much memory the machine has? And maybe you could reproduce it on a faster machine if you just tricked it into thinking it had less memory?
I did, because it does seem to be related to free memory. On one VM I have, it only reproduces right before the kernel proceeds to permanently scream and yell because it has run out of memory for higher order allocations. But I have reduced the amount of RAM on the VMs, and Linux has a nice flag on real hardware that you can say, I have this much RAM, I promise. It does not appear to significantly impact the outcomes. It might make it faster on the ones that reproduce it normally, but I don't. Sample size hard because variance high.
Mm-hmm.
Like the Spark I have, for example, is 1 gig. But producing a VM with that does not necessarily make it reproduce. It's cumbersome. Which is why I was hoping to find somebody who might be more familiar with the code to look at it, or at least help me look at it, I should say. I'm not trying to punt it all off to someone. And the funny thing is, I don't even use encryption either.
Well, I definitely appreciate your investigation into this and bringing attention to it, Rich.
Thank you. I just wish I had something more productive to say then. Please help. I've been looking at this for months now.
In
Curiosity, sorry, Matt.
No, go ahead.
I was just going to say, out of curiosity, do folks know if like some of the like NAS vendors are offering encryption as part of their offering with ZFS? Like IX Systems, I mean, are they using encryption?
Yes, we are using that. Not for a long time, but we do now. That's optional.
Do you use send receive to pass backups around?
Yes. So I can't say that that everything is great there. We saw some rough edges, but it's not terribly broken, I would say.
I am really curious what the underlying reason is that a lot of people don't have problems and some people really do.
Yeah. And there are some people that see problems repeatedly, right?
Yeah, like there are some people, if you look in the issues, who just come back and say, yeah, it did it again today, tomorrow, the next day. But, I've tried on my x86 hardware and it doesn't, no.
Yeah. It's very interesting. Like it makes you wonder if there's something specific about their setup, or is it just like very subtle, like the timing and the block sizes and the pattern of, file creation and deletion that could be very hard to reproduce outside of their workload.
I've been trying to work through the combinatorics tree of what could this be, but.
Are they all on Linux, or is anybody reproducing it on FreeBSD?
I think all of the ones I've seen reproduce it are on Linux. Well, that's not entirely true, right? I mentioned all of the ones that I was discussing before on Linux, but I did mention the person or the people reproducing something that looks very similar on Illumos for the one where the buffer gets the wrong ref count.
Mm-hmm.
I'm kind of curious because the Illumos one got a bunch of activity and then hasn't been touched in 4 months. So I don't know if they just migrated off and didn't keep looking or what, but.
Do you know what the Illumos ticket is offhand?
I think it's 14,003.
It could just be we just ran out of time to.
Yeah, they said they were encountering it on a customer system though.
Okay, so okay, Alex. Yeah, oh, and it looks like Josh also did something. I can ask them. I know both of them. I used to work with both of them, so I can see if they made any progress.
I would be curious to know, thank you. I know that I looked and didn't see any commits land in SmartOS or Illumos about it that I could find.
No, I think they may have just ran out of time or with other stuff. But yeah, Alex is in Australia, so I'll ping him probably this evening, North America time. So
All right, thank you.
Cool. Well, I think we're almost out of time for the meeting, but thanks a lot for bringing this up, Rich. I think in the absence of anybody like standing up to really take ownership of this, I think we should continue to bring this up at future meetings, just to continue advertising this opportunity for
more engagement.
Yeah, exactly. And to make folks aware of the work that you're doing and that people are still hitting this. And obviously encryption is like a big important feature of ZFS. But like a lot of the ZFS features, like the importance varies widely among people using it, right? Some people
like, I think
like don't care about it at all, and other people it's like, yeah, this is really critical to my use case.
Like so many things.
Yeah. Cool. I think that in the last minute that we have, let's let folks solicit code reviews. I think there are a few things in here.
Yeah, so mine's just a small one.
Go. Thanks, everyone.
Yep, so
right, thanks so much.
It basically, instead of using a static allocation inflation value of 24 times the logical size of the block, each VDEV type advertises what its inflation would be. So, RAID Z3 is 4 times the A shift, and it uses that value, the worst VDEV in the pool, to calculate, using the same math as before. And since we have access to the object set, it also looks at what copies equal to set2 for that object set. And so with that, you can generally get the inflation down to 1 to 3x instead of 24x. And that means when you're running close to a quota, the performance doesn't fall off the rails nearly as quickly.
Alan, is that inflation dynamic as you add like VDEVs and VDEV types?
Yeah, so if every time you open a VDEV, it checks and increments the worst VDEV if the new VDEV is worse.
Cool.
So yeah, it just keeps track of a pool wide, what's the worst minimum allocation size for any VDEV in this pool, and uses that value. And it changes the math to round up to the nearest that many sectors rather than just straight up multiplying the logical size by the worst case, right? Because if you end up needing 7 sectors and the RAID Z's gonna bump that to 10, you don't actually want to multiply the size by 10. You want to round it up to the next 10. And I saw in the older Delphix fork, the static 24 was just dialed down to, I think, 2. Because you're like, we're never going to have dedupe, we're never going to have RAID Z and so on.
And that's worked just fine for us.
And dedupe ditto was removed a while back, so the default should have been at least only 12 for the last while, but it doesn't even need to be that high.
Cool, thanks, Alan. That'll be a nice change to get in.
Yep. Alec?
Yeah, and I have an update. Last time I talked in one of these calls, we were talking about the corrective receive patch, and that there was a test that was failing. I was trying to figure out what was going on there. So all of that has been addressed. So it's ready for review again. for, I don't know, people that may not remember, corrective receive enables us to heal permanent data corruption using like a send file or something. And there's a talk that's linked in the PR for more context on this. You could go listen to it and watch it. But yeah, any help in moving this forward, or anybody that wants to review it is appreciated.
I don't see the talk link. Oh, here we go. It's a little bit down. You might want to just copy those links into the first comment, that with the description and everything.
Oh yeah, I'll do that. I'll edit it.
Because there's yours is the last, the one with the links is the last one before there's 96 hidden items. So it's probably not long before that one's going to get hidden too.
I guess it gets hit enough where GitHub doesn't want to hide it.
Yeah, I think, yeah, I don't know. I think GitHub might just be like, oh, when there's more than however many comments, it's just like, you get the first 3 and then you get the last 7 and anything in the middle is just like, well, you have to click to expand.
Maybe.
Yeah. I only said because there's, you only ever see the one hidden items thing. You don't see hidden, and then here's one comment, and then a bunch more hidden, and then there's one comment.
Right.
Unless they were explicitly hidden by, by somebody. But the we don't want to display, we don't want your page to be more than 20 meters long or whatever, hiding. All right, cool. Well, thanks everyone. And we'll see you 4 weeks from today at the later meeting time.
Thanks, Matt.
Happy New Year, everyone.